Okay, so today we're going to start our unit on matrices. I know we did a short unit, or short introduction on code breaking, and we use that, how math is used in code breaking. So today what we're going to do is we're going to start with matrices because I'm going to teach you through matrices, not right away, about how to create and break some very complex codes. So we need to start with what a matrix is. A matrix is simply an organization of numbers in a box. So we'll start with just a real basic matrix. So here I have a matrix that has 4 numbers in it, 2, 5, 6, and 7. You'll notice this matrix has it has rows and it has columns. Okay. And if I were to talk about this matrix in itself, I may give it a name. Okay, matrices are usually named with uppercase letters, so maybe I'll call this matrix A. And maybe I want to talk about what this matrix looks like. So matrix A has 4 numbers in it, obviously. Now matrix A has rows and columns. So typically if I'm going to talk about the dimensions, okay, of matrix A, I'm going to talk about the rows and the columns. So this is considered a 2 by 2 matrix. Okay, so matrix A would be considered a 2 by 2 matrix. Let me draw another matrix for you. 0, 1, 5, -2, 6, 10. And by the way, just so you know, you can have any types of numbers in matrices. We can have fractions, we can have decimals, positive, negatives, anything like that. Typically, you won't see decimals and fractions, but they can show up. Now, this one has 3 rows and 2 columns, so we'll call this matrix B. So matrix B would be considered a 3 by 2 matrix, okay? The first part of your homework tonight on Khan Academy asks specifically for that. You'll be given pictures of matrices, and you need to tell what the dimensions are, okay? Fairly straightforward. You actually have 3 assignments on Khan tonight. Each one you have to get, I think the first 2 are 5 in a row, correct? The second one is 3 in a row, or the third one is 3 in a row. So the first one is just going to ask you to look at matrices and tell what the dimensions are. Okay. So now that we have a feel for what a matrix is, I know it's very abstract. I know it looks weird. Just for future reference, these are used in solving linear equations that have more than 2 variables. So if we wanted to solve a variable with 3 unknowns, or equations with 3 unknowns, we would use a matrix C. Or a matrix. If we wanted with 4 unknowns, we would use a matrix. They're much simpler to use than trying to solve them longhand. So, alright, so now we know what a matrix looks like. How can we use it? What can we do to it? So the very first thing we're going to talk about is scalar multiplication. Now this means that I'm going to take a matrix C, or a matrix. If you want to, one matrix is a matrix. 2 or more is matrices. So I'm going to take a 3 by 2. We'll do 5, -6, 4, 0, 2, and 5. Okay. So let's say that I wanted to take this matrix and we'll call it matrix C, and I wanted to know what 2C was. Okay. So what I'm going to do, this is basically saying 2 times C. The algebra rules are very similar. Okay, 2 times C. So I'm going to multiply every term on the inside of the matrix with 2. So 2C would be 10, -12, 8, 0, 4, and 10. Pretty easy, yes? I don't think I need to go into any more depth on how that works. Basically, you have a matrix, you multiply it by the scalar number, multiply everything on the inside by that number. So this is another part of Khan Academy. Again, there's 3 sections on Khan tonight, but I think it's fairly easy, and I wanted to get the easy stuff out of the way. Okay, the last thing that we're going to talk about is addition and subtraction with matrices. Okay, and this is actually with matrices themselves. So matrix, addition, and subtraction. Okay, so first of all, you should know you can't just add a number to a matrix. I can't go 3, 2, 5, plus 6, and then just add 6. That doesn't work, okay? With matrix addition and subtraction, it is very, very important that you have 2 matrices, and that the matrices have the exact same dimensions, okay? I cannot add a 2 by 2 and a 3 by 3 together. I also cannot add a 2 by 3 and a 3 by 2. I could add a 2 by 3 and a 2 by 3. They have to be the exact same dimensions, and you'll see why in just a second. So let's say we're going to take this matrix, and we're going to add it to another one. 5, 6, 0, -3, just for kicks. Okay? So when I add two matrices together, I'm going to come up with a new matrix. Okay? Alright? And I'm going to add like terms with like terms. So wherever it is in the first matrix, I will add it to where it is in the second matrix. So 3 plus 5 is 8. 5 and 0 is 5. 2 and 6 is 8. Okay. So 9 and -3 is -6. There you go. Now I've added two matrices together. Now can you see why I can't add matrices with different dimensions? Okay, they have to go in the exact same place that they started at. So this is not the same for multiplication of matrices, but that's a whole other ballgame. So if you're adding two matrices together, they must be the same dimensions. Let's go ahead and do one more example. We'll do a subtraction problem this time. So and we'll do a I'm not going to go as far as a 3 by 3, but we'll do a 3 by 2. Minus. Okay, so my new matrix is going to be a 3 by 2 as well. That's always very important that we have the exact same number of spaces and number of terms that we have. So we're going to go 3 minus 5 is a -2. So I did this one and that one. Okay, keep them in the same place. 2 minus 10, -8. Okay, and in order does not matter. I could go down and then across, just as long as I make sure they get in the right spot. 5 minus -2 is a +7. 6 minus 0 is still 6. -4 minus 9 is a -13. And 8 minus 6 is 2. And that's it. I don't think I need to go into any more detail. Again, this is fairly simple. I know it's new. I know it's different. Okay. I hope I did a good enough explanation so that you can at least do some addition and subtraction with them. So 3 areas on con tonight. Good luck.